Hello everyone and welcome back to Thermodynamics channel. In this tutorial, we are going to use EES or Engineering Equation Solver to construct a TS diagram for a refrigerant 134A. We will plot three different thermodynamic property curves on the same diagram: a constant pressure line at pressure 1000 kPa, a constant specific volume line at volume equal to 0.014 cubic meter per kilogram, and a constant enthalpy line at 220 kilojoule per kilogram. We will vary the temperature from -40 to 100 degrees Celsius. We will use the EES to generate the diagram and investigate how the slopes of the constant pressure and constant specific volume curves compare within the superheated vapor region. In today's tutorial, you will learn how to use function information library and data in the EES software, use parametric table to generate the data from some function like TS, and then draw a XY plot for a constant pressure line at pressure 1000 kPa. And then you will learn how to use overlay plot to combine these three different plots in one TS diagram. And finally, we will use a very useful type of diagram in the EES software called property plot, and then compare that property plot with the plot TS diagram that we create manually in the EES. So now let's open EES and start building our TS diagram. So we can start with plotting the constant pressure line at 1000 kilopascal. So to do so, we need to create a TS diagram. And so to have this TS diagram, we need to have an equation with two variables, temperature and S or entropy. So we can start in the EES software. So as you know, we have a very useful database, function information. You can go to our previous tutorial materials in the Thermodynamics channel and find out how you can use this function information. But very simple, you can use thermophysical properties in this problem. And as you know, here this is the real fluid, and you can find your refrigerant here. In this example, it is R134A. So I will go down in this list and then find out this refrigerant 134A, a little bit down here. Then I can select it, R134A. And to create a TS diagram, I'm going to use one function here, entropy. So this entropy, I have both entropy and the temperature and one variable, and I will use the second variable as our constant value. So I can simply paste this equation. This is an example. When you see something here and press this paste, you will have it in the equation window. So I will simply press on the paste, and then I have this entropy actually here. So because I have different constant lines, and I will use the same function for all. So I can simply change this function to S underscore P, which represent the constant pressure for this equation. So for having a constant pressure line, so in this line, always the pressure is 1000 kilopascal. So I can just simply call it as 1000. And as you know, if you go to this SI, or preferences, you will see the default units here. So as you can see, the pressure units now is kilopascal, and the temperature unit is Celsius, and the energy units also is kilojoule. So I will close this window pressing OK. So I have this temperature, a constant temperature for this equation here. And then here, as you see, I have one equation with two variables. You can check it by pressing on this button and check this one, you will see there is one equation and two variables. So you cannot just directly solve this equation. You need to give the input value to temperature or S, and correspond to that input value, you will receive the result. So to have a actually plot, I can define a parametric table and give this temperature as the input value, a range between -40 and 100 degrees Celsius. And for each of the input value, you will get entropy for that specific value, and then you can plot your data. So now I have this equation here, and then I can go to the tables simply here, use the new parametric table. So here the first option is number of the runs. So if you increase this number, I will change it to 100. So you have a table with 100 actually rows. So you will divide the input value between more cells. So your results will be more precise. So then in this case, I will use these two variables in the equation, S_P and temperature, and then add it to the variable in the table. So after that, press OK, and you will see I have a table 1. You can also change this one, right click and change this table name if you are interested in, but I will keep it as it is. And then I have two variables, temperature and then entropy for the constant pressure. And as you can see, this is run 1 and we define 100. So if I go here, it is 100 runs here. Then simply I will define this -40 and 100 here. Right click on the temperature, use alter values, and then you can select the first value and last value. So it's -40 and 100. So you can select different option here, but I will select this first and last value here. And then press OK. So you will see this table will be fit from -40 to 100. I can go to the first cell also. So for all of this value, we can just simply solve the equation we defined by pressing on the solve button. So you will see this entropy will be determined based on your equation and also this inputs, which is temperature. So now I have a table based on entropy and temperature, and as you know, this is for a constant pressure. In all of these values, the pressure is set to 1000 kilopascal. So this is make it simple to create a constant pressure line at the pressure of 1000 kilopascal. So to create plot, as you know, I can go to the plots here, use new plot window and select XY plot. So here in this EES file now, I have only one table, table 1. So under this parametric table, you can select the different table, but as I have just one table, I can select table 1. And I'm going to have a TS plot. So the x-axis is S_P, and the y-axis is temperature. Then I can simply press on OK. So I have this TS diagram. I can increase a little bit the size of this one also simply here. Then I can use this add text to add a text. So the pressure, as you know, is equal to 1000 kilopascal, for example. So I can call it as like this. Keep the color as black here. Press OK. And then I can bring it here, for example. I can you can increase the size or use the bold option. Press OK. So for this constant pressure line, as you can see, we have it here in the TS plot. Now you can do the same procedure, but this time for the specific volume. So to do so, you can go to the equation window here, equations window. Then I will use the same equation because I'm going to create a TS plot. So here we have T and also S, but this time I will change this pressure to actually specific volume. So I can copy this one, paste it here, change this to V, for example, underscore, and then this time I will select this as V, write it as 0.014 here, and the thing is EES simply understand this input value for this equation. You can use different type of variables. So when you write V, the EES understand that this is referred to a specific volume. So here the specific volume will be 0.014 cubic meter per kilogram. So I will do the same procedure. Go to the table, use a new parametric table, change this 10 to 100, and this time I will select S underscore V and T variable in this equation, and then add to the table. Press OK here. So this time we have T, temperature, and then entropy for the constant specific volume. I will do the same, alter values, minus 40 and 100, and then press OK. So I can solve this equation for the constant specific volume and this temperature. Solve this equation and we will get all this entropy for all of this temperature at a constant volume. Then I can draw the TS diagram for this constant specific volume, but in this time I'm going to combine these two diagrams together. So you can just simply go to the plot, and this time you have this option, overlay plot. So you will select this one, and when you use the overlay plot, actually you can combine this diagram to the previous diagram, which is the plot 1. So for the x-axis I will select S underscore V, and then for the y I will select temperature. So this is the symbol, color, and then press OK. And as you can see, this is the actually constant specific volume line at a volume of 0.014. So this time I can use Ctrl C, Ctrl V, bring it here. Then you can change it to V, for example, and then change it to 0.014 and then a cubic meter per kilogram, for example, like this one, and then press OK. You can change the color also to this one, press OK. So we simply combine these two constant lines in one TS diagram. As you can see, this is S underscore P because we start with this constant pressure line. So you can just simply change this one, double click on this one, and then change the axis text from S underscore P to just simply S. You can also give the unit also here. I can also double click here and then write the unit, for example. So it is kilojoule per kilogram Kelvin, like this. Press OK, and also change this one to like temperature Celsius, something like that. Press OK. Here also we have, and then we'll do the same procedure, but this time for the constant enthalpy line. So I will go again to the equation window here, copy one of this equation, V, Control V, and then change this one to S underscore H, and then change this input value from V to H, and then I can call it as 220. So the same procedure, I will create a new parametric table for this one, change it to 100, use this time S underscore H and T, and add it to the variable in the table, press OK, right click, give the input value for temperature, which is minus 40 to 100, and press OK, and solve this equation here. So now I can simply add this one also to the previous plot. I will go to the plots, use overlay plot. Then this time I will select S_H based on the y-axis is T, red color for this one, press OK. I can just simply copy this one, Control C, Control V. Then this time I will change it to H with equal to 220, and it is kilojoule per kilogram. Then I can also change the color to red one. So now we have a TS diagram for these three constant lines, which is pressure, a specific volume, and enthalpy. And you can also in this area is for sure is a superheated area, and you can see you can compare the slope of this two constant line for pressure and the specific volume here. But a very simple way to have these lines, these two constant line, is actually use the property plot, which is a very important plot in the thermodynamics and also in EES. Very simple. You can just simply select this one, property plot, and then you can select your refrigerant here, which is in this case R134A. I will select this one. And then here you have this show lines constant quality as a default. You can deactivate. We are just going to have the constant lines for pressure and the specific volume here. So here as a default we have this one pressure constant lines here. So you will have different values for the constant pressure and also for the specific volume. You can just simply deactivate all and this one. Then you can just simply define your constant value here, which is 220 for our pressure here. 1000 kilopascal. 1000 kilopascal, and the specific volume is 0.014. So I can just simply type 0.014 and you have the units also here. So here in the type of the plot you have different options. I will select the TS diagram here first and then select the constant pressure line and volume and deactivate this constant quality and then press OK. So you see the EES simply create a actually property plot for this refrigerant, and it is a TS diagram. The unit given here simply by the default, and then you have this constant pressure line, which is this one, and this is the constant specific volume line, which is this one, and this is the same as this line that we have created here. And then in this superheated region you can compare the slope of these two diagram together. So here also you can just double click here and change the color and and all the details for actually this plot simply here. So yes, that's it for today, and I hope to see you in the next tutorials.